Okay, this is theorem 1, and we are required to prove that the opposite sides of a parm are equal. ABCD is a parm. Okay, so because it's a parm, one property we know of parms is that the opposite sides are parallel. So let's add it into the diagram. And those arrows added in there means that the opposite sides are parallel of a parm. So because we are told that it's a parm, I can only use the properties of a parm. So we are going to try and prove congruency between this triangle and that triangle. So we always start off with in this triangle and in that triangle. So if you look in those two triangles, triangle ABC and triangle ADC, do you notice any angles that are equal? Do you notice alternate angles? So if you follow it, you look here, you can see the Z shape, right? And the opposite sides are parallel. So therefore we can say that A2 is equal to C3. So A2 is equal to C3, right? So A2, C3, okay? A2, C3. Those are alternates because the opposite sides are parallel and they are alternate angles. Can you find any other angles that are equal? How about A1 and C4? And those will also be alternate angles. AD parallel to BC. Right. So now we have two angles. So we cannot have congruency with three angles. That means we definitely need a common side. Do you see a common side between the two triangles? How about AC? Isn't that the fold? And that will be common to both triangles. So AC is common, and that will be our side. Okay, so now we have two angles and a side. We have two angles and a side. We can then conclude that these two triangles are common, are congruent, and we will take that statement. Right, we can conclude that this triangle is congruent to that triangle, and our reason is angle, angle, and a side. But if you look at the diagram, it's an angle followed by a side followed by an angle. So angle, side, angle. This symbol here means congruency. Three horizontal lines. So those two triangles are congruent. Now, if the triangles are congruent and we were to cut them out and put them on top of each other, we will notice that AB would be equal to DC. Okay, so we're going to have to write those statements. Alright, so AB would be equal to CD and BC will be equal to AD. This would be the corresponding side of the congruent triangles. Okay, now we need to prove that the angles, the whole of angle A is equal to the whole of angle C. Notice that was the second thing we have to prove, and then we have to prove that B is equal to D. I'm going to clear the board. Notice that A1 was equal to C4, A2 is equal to C3, so that means all of this is equal to all of that. And we proved that above. So our reason is proven above. Therefore, angle A is equal to angle C. Now, if this triangle is congruent to that triangle, that means this angle will fit perfectly on that angle. Okay? So angle B is equal to angle D. And our reason there will be angle B, angle D equals angle D, corresponding angles of congruent triangles. Okay, because if I fold this paper over, B and D fit perfectly on top of each other because they are congruent, and that is theorem 1. So all you have to do is practically study that process, how to do it, and practice it a couple times. You'll definitely get it. Good. Okay, this is an example in the Mind Action Series book, page 194. Just want to explain it as a baseline example so that you can continue with exercise 2 on page 195 of the Mind Action Series textbook. Right, so let's look at it here. They tell us, example 2, they say prove that ABCE is a parm. So they want us to prove that ABCE is a parm. Right, so notice this one will be given values. Always work with the given to try and find the unknowns. Okay, so notice they gave you these two marks. Why? Because they want you to find E2. That's the reason. Who can tell us the value of E2? E2 is 70 because that's an isosceles triangle. Okay, so now we know that E2 is 70. Don't forget, for isosceles triangle, we say equal angles opposite equal sides. So this is 70, that one must be 70. Who can tell us how much is E1? E1 will be angles on a straight line. 180 subtract 70. So that means E1 must be 110 angles on a straight line. Now we have 70 and we have 110. Those are co-interior angles. You agree? So if this one is 110 and that one is 70, they add up to 180. If co-interior angles add up to 180, the conclusion is that the lines have to be parallel. So if co-interior angles 70 plus 110 add up to 180 co-interior, that means that AB must be parallel to EC if these two angles add up to 180. So in earlier grades we said because the lines are parallel, the angles were co-interior. You see, because the lines were parallel. Now we're saying because the angles add up to 180, therefore the lines must be parallel. Okay, and so if we got the second set of lines being parallel, that means that must be a parm. Therefore, ABCE is a parm, two pairs of opposite sides that are parallel. So therefore that whole shape will be a parm because that one's parallel, and now we prove that one parallel. Not that difficult.